Hello everyone, myself Juli Yadav. I am assistant professor at Ajay Kumar Garg Engineering College, Ghaziabad. So today's topic of presentation is code generation, which is the final phase of the compiler. So what does this code generation is? So code generation is the final phase of the compiler, design of compiler. What does it do? It converts the intermediate representation of source code into a form that can be readily executed by the machine. A code generator is expected to generate the correct code. Means a code generation is the final phase of the design of the compiler. What does it do? It converts the intermediate representation that can be in any of the form, like it can be linear representation or graphical representation, or the intermediate representation is like that can be in the form of 3-address code, DAG and many more. So intermediate representation is the input for code generation phase. It converts that or it execute that into a machine code, means a target program that is easily read by the machine. Means the input for the first phase, that is the your source program, is converted into a target code, that is the code that is that can be understood by the machine. So the following points need to be considered. The code optimizer accepts intermediate code. What does the code optimizer do? It accepts the intermediate code. The front end, you know, I have just told in my previous video that comprises of lexical analysis phase, syntax analysis phase, semantic analysis phase and the intermediate code. Means the output of front end is the intermediate code. This is the output for the front end phase. So it accepts the intermediate code. Which accept the intermediate code? The code optimizer accepts the intermediate code representation which is generated from the front end of the compiler, and it produces another intermediate code representation which is optimized. Means it just optimized the intermediate code, that is the code that is written in 3-address code. It just, the code optimization just optimize it means it reduces the number of codes. It reduces the number of code. This is the optimization. So the code generator takes intermediate representation, means the optimized intermediate code. Here we can say the optimized intermediate code is the input for the code generator along with the relevant symbol table information. Means the input for code generator is the optimized intermediate code plus the entries or the information present in the symbol table. These both are the input to the intermediate code generator. It takes intermediate representation produced by the code optimizer along with the relevant symbol table information and produces semantically equivalent target program as the output. What does it do? It takes both as the input, the optimized intermediate code and the information stored in the symbol table, and produces the target code, the code that is needed by the machine. Or suppose if we have designed a compiler for C language, so the target code is the compiler for that C language. Means it is the program that is written or that is understandable by the machine. So the first topic in code generation is the design issues of code generator. These are the design issues. The first one is the input to the code generator. Means obviously it is a design issue. As we know that input to the code generator can be of any type. I will discuss it in later. Target program is also the design issues, the memory management, instruction selection, register allocation and evaluation order. All these are the design issues of code generator. So let's discuss the first code design issue of the code generation, that is the input to the code generator. So basically The input to the code generator contains the intermediate representation of the source program and the information of symbol table. Means the input to the code generator, I have just told you, the input to the code generator is the optimized, we can say that it is the optimized intermediate code and the information present in the symbol table. So, these are the inputs for the code generator. The source program is produced by the front end. As we know, I have discussed in my previous slides, the source program is the it is produced by the front end. So, the input to the code generator means the intermediate code, which is the input to the code generator, right? That is the intermediate code. This intermediate code can have several choices, means it can be in any of the following ways. Like first one is the linear representation, means the intermediate code can be in linear representation, right? And second one is the graphical representation. So, the linear representation is the postfix notation. The postfix notation comes under the linear representation, and in graphical representation, these two representations comes under the graphical representation, that is syntax tree. And beyond syntax tree, there is another representation of graphical representation, that is DAG. Directed acyclic graph is also one of the representation of intermediate code, and the last one is the 3-address code. So, these are the intermediate code representations, means the intermediate code can be represented in any of the following ways, which is the intermediate code is the input to the code generator. So, the input for code generator can be in any of the following representation. That's why it is a design issue to the code generator. So, let's discuss the linear representation. First one is the postfix notation. What is this postfix notation? The postfix notation is the notation in which all the operands like A is equals to B plus C. How we convert this normal expression into the postfix notation? We just B, C plus means the operand and the operators are separated. Operators are placed at the end of the expression. Suppose if there is another expression, that is D, it means star D and B, C plus D star. So, this is the postfix representation or the linear representation of the intermediate code. Now, next one is the syntax tree, which is the graphical representation of the intermediate code. In syntax tree, we basically design a tree of the given expression, like if this is the expression, then syntax tree for this expression is like A, we start from the operator, so this is the syntax tree for this expression, right? And what is the difference between the syntax tree and the DAG? Why these are the design issues to the code generator? Because we have to design a code generator according to the requirement, means in all the representation, means it can take all the inputs which can be in any of the representation. That's why it is a design issue for the code generator. So, for this particular expression, the DAG can be like star plus, here it is B and here it is C. For the left side it is this and for the right side it is this. Means this is the DAG for this particular expression. Now, the last one is the 3-address code, means how an intermediate can be represented in 3-address code by generating the temporary variables. Like if this is the expression A equals to B plus C into B plus C, how we represent this expression in 3-address code? Like T1 equals to B, T2 equals to T1 plus C, T3 equals to, again we can take B and then T4 equals to T3 plus C, and T5 equals to T2 plus T4. So this is the 3-address code representation of the intermediate code. So now we assume front end produce low level intermediate representation, that is value of names in it can directly manipulate by machine instruction. Means what does it mean? It means the front end produces, means the phases that are in the front end, they produces a low level intermediate code representation. As you can see here, the front end, here is a front end, it produces the intermediate code, then this intermediate code is gives as the input to the code optimization. So the intermediate code that is generated by the front end is the low level intermediate code. So why we are saying it is the low level? Because the values of the name in it can directly manipulated by the machine instruction. Means these the values can be manipulated by the machine instruction. That's why the intermediate code produced by the front end is the low level intermediate code, right? Now the code generation phase need complete error free intermediate code as an output. So so the code generation phase need a completely error free intermediate code. That's why this is a design issue. Means the input to the code generation is a design issue for the code generator. Now next is the target program. What does the target program? Target program means the output output of the code generator. You can see here the output is the target program. So why this is a design issue for the code generator? Because the target program is the output of the code generator, because the target program can be in any of the 3 languages. That can be either in assembly language, relocatable machine language, or can be in absolute machine language. What does this absolute, let me start with the absolute machine language. What does it mean? It can be placed in a fixed location in memory and can be executed immediately. It means, as we know that this it can be placed in a fixed location. Means if this is the memory, then the absolute machine language is fixed. If it is the 100 location, then the code written at this is the fixed, means it will never change. So that's why absolute machine language it basically it uses for small program. It is not used for the large program. Why it is not used for the large program? Due to its fixed place in a location. That's why it is used in only for the small programs, right? Another target code, target program is generated by the relocatable machine code or by the assembly code. What is relocatable machine code? It makes the process of code generation easier. How it makes the process of code generation easier? Because suppose if this is a memory and it has the address 100 up to many. So these addresses are to be, if this is the program address that starts from 0, 1, 2, 3 up to 10, up to 9. So, how the relocatable machine address or the machine language can be generated? If at 100 there is a value A, and if we want to find the program location, then how we will find? We will link, means we add 100. This is the base address or the base memory location. So, 100 plus 0 means at 100 place the value that is to be located is the machine language, and then 1. If we want to find the program address for any of the variable or any of the language, then it can only be found by adding the base address with the program address. And it also needs the relocatable machine code, means the output, if the output is generated in relocatable machine language, then it has it needs the linker and loader. Why it needs the linker and loader? Because if some of the code is stored at some other location, like if some of the code is located at the program address and some of the code is located at some of the memory location, then the things or the program needs to be linked and load into the main memory so that they can be executed. That's why relocatable machine code need linker and loader is essential, and it is a subprogram and subroutines to be compiled separately. Means in this or the relocatable machine code, every subroutine or subprograms need to be compiled independently. They cannot be combined and then can be compiled. They need to be compiled separately. And the last one is the assembly language. It allows subprogram to be separately compiled. Means it also allowed the programs to be separately compiled. Why? Because the assembly language is in the form of instructions like move, add, increment. So, the assembly, if the target program is in the assembly language, then it is more usable and more friendly for the compiler. Now, the another one is the memory management. What does this memory management and why, or we can say why or how it is a design issue for code generator? It is a design issue for code generator because during the code generation process, the symbol table entries have to be mapped to actual P address. Means the symbol, the entries in the symbol table has to be mapped with actual P addresses. Means from where that the information of that particular variable has to be accessed or how it has to be compiled, that thing needs to be mapped. So, the mapping is actually done in the memory management. That's why it is the design issue, and levels have to be mapped to the instruction address because the mapping is done between many more addresses or many more instruction address. That's why it is a design issue. Mapping name is the source program. What does this mapping name is? Mapping name is basically the source program to address of data is cooperating done by front end and code generator. Means mapping, how the things has to be mapped, means some of the things are generated or the some of the code is generated in the front end phase and some of the code is generated in the code generator phase. Then how these two phases are linked? They are linked by the mapping names. That's why the memory management is one of the design issue. Now, the local variables are stack allocation in the activation record, while global variables are in the static area. And there is an activation record that has some of 7 fields. So, these activation record is basically used if we are suppose we are compiling or we are running any of the program, and suddenly a query or another program wants to execute, then the currently running program all the information related to the currently running program need to be stored in the activation record, and then the access is passed to the another program that wants to be compiled. So, there is a important role of activation record. I will discuss it in the later videos. So, the local variables are in stack allocation. The activation record has few of the fields in which local variables are stack allocation in the activation record, while global variables are in the static. It has many other allocation areas there are many other allocation areas in the activation record that has different values, means the stack area has the local variable and the static area has the global variables. Right. Now, the next design issue is the instruction selection. Nature of instruction set of the target machine should be complete and uniform. What does it means? Instruction selection means it is a design issue for code generator, because suppose if there is an expression A equals to B plus C. So, what kind of instructions can be generated? Like what we need a register to store the value of these variables, right? So, what we do? Move B comma R0 means we have shifted the value in B to the register R0. Then this value has been shifted to the register R0. Now we add R0. We add R0 with C with R0, means the value in R0 is to be added with the another variable C. Then that value has to be moved, means after adding B plus C, this register R0 has some value that has to be moved to A. So, these are the instructions for this particular code. If there are some other codes like A equals to B plus C and D equals to A plus E, if these are the instructions, then if we are designing the instruction, these are the means the instructions, or these are the expressions of the same program, then the instructions for this is move A comma R0, then we add E comma R0, then move R0 comma D. So, these are linked. Now, we can see here the statement. Here we are moving the value of B into R0, and then we are adding it C with R0 and storing the value of B plus C in R0 register. Then what we do? We move the value from register R0 to A, right? And then what we do? We are adding the value of A to the E, and what we are doing? We are moving the value of this A into the register R0, and then we are adding the value of E with R0. So, here you can see, or we can see here, this instruction. Instead of this instruction, we can, the instruction selection can skip this instruction. Why? It can skip this instruction, as well as it can skip this instruction also, because there is no need to because there is no need to write the instructions again and again, right? Both the instructions means the same. The values of A is moved to R0, and in this the value of R0 is moved to A. Instead of these two instructions, we can write the instruction move B comma R0, add C comma R0, add E comma R0, move R0 to D. So, the instruction selection has been done in this way. Next is the register. So, register can be accessed faster than memory, as if we are accessing the registers and if we are accessing the memory, then the accessing of registers can be easy than the accessing of the memory. So, the instructions involving operands in register are shorter and faster than those involving in memory operands. Means if the instructions involve the operands in registers rather than operands in memory, then it becomes the faster to accessing the registers. So, the following sub problems arise when we use registers. That is, these two problems will arise. First one is the register allocation. In register allocation, we select the set of variables that will reside in register. Means in register allocation, we select those variables that can reside in the register. Another problem is the register assignment, means which register has to be assigned for which instruction. So, in register assignment, we pick the register that contains variable. Certain machine require even odd pair of register for some operand and result. So, most of the machines use odd and even pair of register instead of normal regular register for operands and results. So, the last design issue is the evaluation order, means in which order the instructions has to be evaluated. So, the code generator will decide the order in which the instructions can be executed. Like the efficiency of code, target code can be affected by the order in which the computations are performed. Some computations orders need fewer registers to hold result of intermediate code than others, means in which order the instructions has to be executed. As I have just told you here, the code generator select the evaluation of order, or means in which order that these instructions are to be evaluated. This can also can only be done or selected by the code generator. So, these are the design issues in code generator. Why these are the design issues I have just discussed. Thank you so much.